treat, little bonus for all of us. It is my pleasure to invite back to this stage Professor Karl Friston, together with Travis Oliphant. Karl, Travis, please. You missed me, Karl.
I did.
You thought you were done, but... This is the moment where I allow myself to put my science geek hat, because the one thing that I know about these two gentlemen is that they are at the core of open source products, solutions, that I've been using as a scientist and also as an entrepreneur. As a neuroscientist, I used SPM, which is a package to process brain data, put simply, that Karl gave to the world. And as an entrepreneur, someone who codes, I've used a lot of the packages that Travis has given the open source community. Too many to list, but there are a lot. I mean, Python is the obvious one. And I wanted to bring you guys together because I'm not sure people know that you were involved with neuroscience at some point and that you used some of the things that Travis did. So let's start with you. What's this thing with you and neuroscience?
A lot of people don't realize I got into Python because I was at the Mayo Clinic studying biomedical imaging and actually did a rotation through a neuroscience lab as well. I thought I might become a neuroscientist, but I was terrible in the lab. I glued the gel paper in the wrong way and messed up the centrifuge. But I fixed their computer. So I better stick with my lab, with what I know, and not the wet lab work. But I worked under a professor, Richard Robb, who had built a software package called Analyze that was one of the first medical imaging and scientific imaging packages that was widely distributed to scientists. It turned out, I just found out that Karl used that library. So it was an interesting serendipitous synchronicity.
So I was in my late 20s, and I'd just finished my medical training, and it was my very first research job, and the very first bit of software I used was Analyze from
Richard Robb, and he was a mentor of mine when I was doing my PhD.
And I think it's an opportunity to stress how important open source and open science are, because a lot of the technology that is built today that you're using wouldn't exist without people sharing their code, without people sharing their science. We hear a lot about AI being monetized and the financial impact, especially here in Davos, which makes sense. But all of this would not exist without people giving their time, effort, and when I say people, it's entire communities. Because for what you develop, for SPM, the community of neuroscientists was sending feedback and plugins, and we all been benefiting from this with thousands and thousands of scientific publications and thousands of products. So you share in common to have contributed to the community, and we shall all be very grateful about that. But Karl knows it. You started to know me a bit better. I'm sure there are points where you guys disagree.
Not yet.
Not yet? Well, this is why I'm here with you.
This would probably take another 2 hours before we get to that part of the conversation.
I'm kidding. So what I want to ask you, you wanted to be a neuroscientist, but even if you don't have a title, I've spent hours speaking to you about the brain, and you deserve a title. What is the way you, as a computer scientist, see the brain? Do you see it as a processing machine? Do you see it as a dynamical system? What is your approach to brain and cognition?
That's an interesting question. I guess I see it as a student trying to understand. So I'm still trying to understand what it is, right? It's a biological, complex, dynamical system that I have myself certain experiences with. I can see it in my own life, and then I can observe my own experiences. Then I can also see it in others, and so it's this experiment I'm in the middle of. And I love the neuroscience I've studied. I've done a lot of lay reading about the brain and how it works. and we were sharing some of our common interests in that direction. I believe the more we understand about how our brain works, the better we can do lots of things. I'm a parent of 6 children, and actually my neuroscience studies, I think, helped me understand my children as I watched them grow. For example, every child goes through this so that's why stage. And it helped me understand that we do the same thing. And I sometimes call it our baloney generator. We all have something, we have to make sense of the world. And I watch my kids do the same thing. They'd see some event, they'd see, oh, the light turns on when somebody comes in the room. And they'd immediately come, oh, that's why. That's why Santa Claus goes down the chimney because of this. And it's like our brains have to be constantly creating a model of the world, even though it's wrong, and it will be. And I realized, oh, I'm doing the same thing.
Speaking of a model of a world, we have the man who basically created the model of a world.
But I'm fascinated we can get better at it, though. And I think we can get better at creating a model of the world.
Yeah, but what is also very interesting to me is someone who's revered the way he is in the world of science, beyond neuroscience, like Karl, making, no offense, the switch to out of academia into business late in your career, and seeing that all these pieces that we learn from the work of Karl in neuroscience are tying up in what Versus does, in what Google DeepMind does, in what everyone does, because at the end of the day, neural nets, guys.
If I could get, Karl, I would love to hear how your system works. I really would love to hear that, because I don't feel like I've heard an explanation. And I would love to hear your explanation of how your system works and what it does.
You geeks out there, this is for you.
And I can answer as a scientist, can I?
Please,
answer it as a scientist.
This is not the moment where you're going to speak to an 8-year-old.
Right, thank you. Although I think 8-year-olds are important things to speak to in terms of, remember at the end of our conversation, I said aha moments, the thing I couldn't live without.
Absolutely.
I think when that awareness, that childlike delight, and say, that's how it works. That's what I meant by the aha moment. So that, for me, is a manifestation of how we continually, and specifically our children, build their world models and build their generative models. They are little scientists trying to discover their world. Very much along the lines that you described your brain, trying to understand the world. And what's the most important part of the world? Well, it's me. So I'm trying to understand myself. Why would I want to understand myself? Well, in order to disambiguate me from you. And so I think there's something quite fundamentally social about the lived world that we're trying to emulate and to install in our generative models that has a distinction between self and other. We were talking about the James Anderson cell. And I was going to ask you, well, now think about the me cell and the difficulties of representing myself without going into Gödel. We don't want to...
We're getting into the concept of consciousness, and what does it represent? But it might be in this direction, perhaps.
Oh, I've got a look from him. So back to the question. So the way that you'd put this into a bit of computer science is to say, okay, the agenda is to build a world model. I call that a generative model in exactly the spirit that you were talking about, generating explanations for that's how it works. How do you build a generative model? You have to work out the mechanics of belief updating as you accrue that knowledge and you make inferences about the world. So there's a lot of stories about predictive processing, predictive coding from the inference perspective, a lot of stories about learning the parameters of that generative model, say, weights in a transformer architecture. The both basically aspects of belief updating, Bayesian beliefs in the way that we were talking about them before. How do you do that? You just have to build a graph, a network. You can always articulate a generative model as a graphical model, a probabilistic model, again with this uncertainty imbued in it, because we're talking about a graph where each node is basically a belief structure, a probability distribution. Then you convert that into a message passing scheme by, for every graphical model, there is a factor graph. The factor graph gives you the message passing scheme for the computer scientist. And then it's a question of just finding the right software. And I have to say that we have identified NumPy and Python as a very apt kind of software to do that message passing on the right kind of factor graphs, whose structure is the world model, and therefore will be unique to this agent who's building a model of her world.
Okay.
And that's how you do it.
That's beautiful. Yeah, I appreciate that. And those who may, if you didn't, let's keep talking. I really appreciate that. That was the most succinct explanation I've heard for a long time.
Well, this is Karl.
Yeah,
This is Karl. There should be drinking games when you listen to Karl whenever he says Bayesian. Really.
So I love Bayesian. I've studied statistics that's another one of my passions is statistics, but I actually prefer it to be called probability theory because I believe, as Bayes' rule is essentially how you reason about uncertainty. And, Richard Koch's theorems, if you've studied those, I'm sure, he proved that under a certain set of conditions, that Bayes' rule follows logically from just if you want to reason about uncertainty consistently with numbers, then effectively you end up with Bayes' rule. So it's not just something that it's actually a mathematically consistent approach to reason about uncertainty. So that's very powerful because, mathematics, I love mathematics, but I'm also recognize mathematics is simply logical thought from starting points. You got to pick the starting points because you can talk about anything you want from any starting point. That's why you can get math to lie because you can hide the starting points from people and then the logic will follow, but you just don't remember that this was the starting point. You actually don't believe that starting point. But anyway, this is what I think. The more we understand about how the brain works, the more we build systems that allow intelligent thought, we can do amazing things for the world. LLMs aren't there, so I actually share that belief, that view. The LLMs are not there. They're amazing tools. That's why I'm fascinated by neuroscientists who are bringing more understanding of how the brain actually works to the world. I'm curious if you can do this in parallel, because of course, what made transformer architectures work today is the massive parallelism, and the ability to do then update massively. Because in the past, these sequential Bayesian models have been harder to program. They've been hard to update. The parallelism isn't there, and so I'm curious if that's if that's been solved or if that's being solved, or what do you think about just the difficulty of the math of computationally updating at scale these models?
Yeah. So can I just take a second to reinforce?
Yes, it's the end of the conference, and this is the moment where I'm thinking about having labels on the talks, for everybody, science geek only, super science geek only, and I'll let you guess in which category this conversation falls. Bring me popcorn, I can be here for 2 hours. I love it.
So we have a latitude to go wherever we want.
Yeah, for the next 3 minutes, sure.
I knew there were boundaries. There are always boundaries with him. But just that point, when I say Bayes, I mean probability theory.
Yeah.
And, I could equally sort of reiterate what you just said about finding the right starting points. That's exactly what people, certainly people like myself and Gabe and people at Versus mean by applying a first principles. You have to get the principles right. One of my favorite principles is actually E.T. James's maximum caliber, minimum injury. That is exactly what I mean by Bayes, or what we mean by
We're
Bayes.
in the same boat. Love it.
It's just the same probabilistic description of the world. This is the only way that you measure your world, you observe your world, you engage with your world. This is the ultimate first principle account. So in fact, the free energy principle is actually dual to James's maximum caliber principle, or principle of minimum path entropy, which is the same as the principle of least action we were talking about, the most efficient way of doing it. It's all the same thing.
All the same thing.
It's all the same thing.
Beautiful.
The large language model thing, I think that the nice thing about the large language model, they have taken a baby step towards a neuromimetic architecture by putting attention heads in.
Yeah.
So they've got a baby step towards sort of contextualizing.
A baby step within a massive engine. A parallelism.
A very big engine. Bigger the better, apparently. Yes. But is bigger better? Well, you clearly know. It is that delicate structure and the architecture of these graphical models, the ensuing factographs that make us what we are. Destroying convolutional neural networks or something is ReLU. functional forms to your updating without any uncertainty, without any beliefs under the hood. That's not going to get you anywhere.
Beautiful.
Just final question, personal interest. I had a conversation with my daughters recently. I'm advising old books for them to understand today's world, and there are two books that I advise them. One is The Invisible Man, that explains a lot the behavior of people on social media. The other one is Frankenstein, who clearly could have been written today with trying to recreate God. Throughout your careers, are there books that are non-scientific books that are really influenced the way you think and that have benefited you as scientists? Something from the literature or else? Karl?
So I was about to say all my favorite books, but they're all scientific of a sort.
Non-scientific.
It has to be non-scientific.
Yes. Oh, anything non-scientific that's really shaped your thoughts? Or...
Yeah, The Hobbit.
The Hobbit.
Okay.
I don't know why, though.
Yeah.
All right.
This might not be Human Action by Ludwig von Mises, actually, has been which got me interested in business, actually. The reason I'm migrated from science to business was actually the influence of economic thinkers like him.
Yeah. The reason I ask is, again, because I always end up on a very analog note, but also because I see too many scientists or tech people who are single-minded towards what they're doing and do not take the step, aside just to learn from different forms of art, etc., that shape our brain and benefit everybody. The reason I'm saying that also is for you out there who are non-geeks and think that this was not a conversation you were expecting. Listening to people who have this amount and wealth of experience and who can take a step back and provide a view, an helicopter view or a microscopic one on what is happening today in AI is really, really a gift to me, and I hope to all of you. Gentlemen, thank you very much for this wonderful conversation.